Alright, so for today's video, we'll be looking at problems where you have generally more than one equation or variable. And I thought I'd start off by saying, of those kind of problems, here's the way that they have to be. These are the problem types that we can solve. You can solve a problem if it has one equation and one variable. And that would be like this first example I have here. The one variable is x. Like you look at it and you don't know what x is, maybe. And then there's obviously just one equation. And then from there, there's a pattern to the type of problem that we can solve. You can solve a problem if there's two equations and two variables. So you look at this next one, and it says, well, there's obviously two equations. And what are the two variables? The x is an unknown, some number that's to be determined, and then y is another unknown. So there's two variables. You can solve a problem if there's two equations and two variables. You can solve a problem if there's three equations and three variables. Okay? And from there, I thought I'd say you get the idea. Why would I say that? Well, there's a pattern. If you had four equations and four variables, you could solve that. You get the idea. Okay? But as you might expect, the more equations and variables you have, the harder it is to do with paper and pencil. All right? But I'll show you. We'll go up to 3 by 3. Okay, 3 by 3, three equations and three variables. In this video, we'll just go up to 2 by 2. All right, now, so about how you would do this, I think that you already should know how to solve that. Okay. But I put it on here because, all the others, all the bigger types of problems really have to just end up being back right there. Okay? I mean, why is it that you can solve a problem if there's one equation and one variable? Well, it's just by the way that you can manipulate it. You take this and you subtract 1 from both sides, and then you divide both sides by 2. And you get that. And then it's like you reduced it to a statement about what x has to be. This is true, this is true. Then all of a sudden it says x has to be 5. And then you just interpret that to be the answer. And it's not hard to check that. What's 2 times 5 is 10. What's 10 plus 1 is 11, right? It's supposed to be consistent like that. Okay. Now, how do you solve something like this? Two equations and two variables. All right. Now, before I do that, I want you to understand why there has to be the same number of equations as there are variables. All right. So I'm going to just off to the side here, I'll do a quick example. X plus y is equal to 10. That's two variables, but only one equation. Do you see why that problem doesn't have a unique answer? Here the answer is unique. 5 is the only number that could ever possibly work in that equation. But, think of all the possibilities there. Could it be true that x is 1 and y is 9? Is that a solution? If you plug those numbers in, does it work? Is 1 plus 9 10? Yeah, that's a solution. But, you see how you could just keep going? And there's endless possibilities? Could it be true in that equation that x is 2 and y is 8? Well, let's check it and see. Put 2 for x, put a for y is 2 plus 8, 10. Yes, so that works too. So there's no unique answer. You could just keep going. And for now, we're interested in the type of problem where there's this one answer that everybody agrees about, all right? So no matter if I solve it or you solve it, we all get 5. That's the one and only answer, okay? All right, now, since this is two equations and two variables, we should be able to do that. The way that it's going to have to happen, though, is we're going to have to reduce this down to having one variable and one equation. Okay, now there's many ways that you can do that. The first method that I'll show you for doing that is what you would see called substitution. if you do my math lab assignments or you look in the book, there might be problems that say use the substitution method, okay? And all that's going to do is knock one of the variables out and reduce it to being one equation and one variable, okay? So let's say, like, here's what we got. We got 2 by 2, 2 equations, 2 variables. And here's how I'm going to use substitution. Here's what I mean by it. Let's say that here's the way I do it. I'll say, for the sake of me keeping track of my work, I'll say that's equation A, that's equation B. And I'll say my method of substitution will be to substitute equation B into equation A. All right, that's my plan. And do you see how you could do that? What's equation B say? It says y is the same thing as 4x minus 6. And you could take where it says y there in equation A, and you could put 4x minus 6 in its place. And what's the word for that? If you like take something and put it in place of something else, there's this word for that. What is it? Substitution. All right, so that's why we call it substitution. So if I do that, here's what it's going to look like. To substitute equation B into equation A is going to say 2x minus 2y. But what's y? According to equation B, y is 4x minus 6. So we'll do like so. That says 2x minus 2y is equal to 9. Okay? Now where are we now? We started with 2 equations and 2 variables, but now we have 1 equation, and how many variables are there? X and x. There's only 1 variable at this point. Okay, now remember I showed you that one first because that's you have to get there. No matter how many equations and variables you start with, you've got to end up with 1 equation and 1 variable if you're going to get an answer. So, okay, now I've got this, and I know that I can solve that with just using things that I already know. So how about this? The 2x, we're going to have to just leave that. Here we'll multiply through negative 2 times that entire quantity. And we'll get negative 8x. We'll get plus 12. And we'll get 9. Okay? And then we'll combine the like terms. 2x minus 8x, we'll get negative 6x. All right. And then we'll move, say, the 12 other side. And we'll get, say, negative 12 over there. 9 minus 12 is negative 3. And then we'll divide. Now it's like we're there. It's like we're almost to the answer. Divide by negative 6. If you do that, you'll get that x is negative 3 over negative 6. Well, if you divide a negative by a negative, that'll be positive. And 3 over 6 reduces to 1 over 2. Okay? All right. So we've got, like, it looks like we have an answer then, doesn't it? All right, 1 over 2. X is 1 over 2. Sort of like up there. The x is 5. That's a definite answer. The problem, though, at this point is that even though it looks like we've answered it, there's 2 things to find, all right? In that initial problem, we're supposed to find what the x should be and what the y should be. So I'm going to do like this. I'm going to say, here's my answer. And I'm going to write an ordered pair of numbers where the first one is whatever the x is supposed to be, and the second one is whatever the y is supposed to be. And that's going to be my answer, okay? And so far, I know that x has to be 1 over 2. All right, now how do you think you could find the y from here? Well, the method at this point is called back substitution. We take this answer, we take the fact that the x has to be a half, and we look back in earlier in the problem for some way to substitute that somewhere and figure out what the y is. Now, if x is a half, I guess you could put that here since it's known to be a half. You could put it here since it's known to be a half. It doesn't really matter. But just think about it like this. If you know that x has to be a half, what looks like an easier way to figure out the y? Would you put it here or would you put it there? Like, which one of these would you use? Okay, I think it'd be easier to use equation B. So let's do like this. So it's like we take this answer, we take the fact that x is a half, and here's how I'll do it. I'll sub that into B, and what's it going to look like? It'll say y, I don't know what the y is yet, equals 4 times x. I do know that the x is a half, minus 6. Okay. And that's how many equations and how many variables are there? There's one equation and one variable right there, so we can chase down that other answer. So this is going to say y is equal to 4 times a half is 2, and y is equal to 2 minus 6, that's negative 4. Okay? All right, and we have both unknowns, both variables, negative 4 for y. Okay. Now, if you're watching the video and you wanted to practice a little bit, here's something that you could try. You could start by saying that, all right, we know x is a half, and I plugged that into B to find y. You could try plugging it into A. You'll get the same thing. Like, this is the one and only answer to that problem. That in combination, the x has to be a half and the y has to be negative 4 in either equation. Okay? So if you were to take that pair of numbers and substitute it in this original problem, it would make both equations true at the same time. Alright? So that's why it doesn't really matter how you substitute. You might just choose to do it the way that's easiest. Alright? Okay. Now, so that's how substitution will generally work. And I want you to notice about this one that it, just by the way it's written, this is ready to just plug in or substitute into that other equation. It says y equals. It's already given away what the y is supposed to be. Alright? So let's look at something a little bit different now. For this one, I guess I could use substitution if I wanted to. I would have to do some rearranging, and I want to not do it with substitution and show you the other way. Okay? So the other way that we can do a problem or solve a problem where it's two equations and two variables is by there's something called the addition, and sometimes it's called the elimination method. I can't remember what it's called on the assignments or book. Both of those terms are used. Here's how that works. Okay, the idea is to take the equations and modify them in a way that you knock out one of the variables. And why would you want to knock out or eliminate one of the variables? Well, because you have to go from having two equations and two variables. You make one of the variables go away and you have one equation and one variable. And then you get a tangible answer. That's why we have to do it like that. Here's how this is going to look. Now, it's not easy to explain this. It's far easier just to show you. Okay? So here goes. Let's say I call this equation A and this equation B. Okay, I need to decide, am I going to try to eliminate the x or the y? Okay? Which one's it going to be? And the way that I'll do that is by figuring out that I can multiply one or the other of these equations by any number of my choice, so that when I then add the equations together, one of the variables will cancel. Okay? Alright, now I said it's easier to just show you. So here's what it's going to look like. Okay? I'll take equation A and I'll multiply by negative 4, and I'll add that to equation B. You can take either equation, you can multiply it by any number that you want, and you can add it to the other one. You can multiply either equation by any number that you want, and you can add them together. Now, why negative 4? Why did I choose that? Well, I'll show you. Okay? So, now if I do this, that will eliminate the variable x, okay? Now here's how. So look at this. Say you take equation A and you multiply by -4. What's that going to look like? It'll say -4x minus 16y equals -32. Okay? So there's -4 times equation A. And then what if you add b to that? You know, b just the way that it is. 4x plus 3y is -7. Okay? All right. So, you know, there. That's what it looks like. -4 times equation A plus b. Now, when we have a problem like this, notice its organization. The x's are in one column. The y's are in another column. The numbers, the 32 and the 7, that's in still the far right-hand column. And we want it to be organized like that if we're going to add them together and eliminate a variable. So let's see. Suppose we did that, where we'll just add, of course, the x's to the x's, the y's to the y's, the numbers to the numbers. Look what happens to that. I get -4x and 4x cancel, eliminate. The x is gone. That was my plan. And then here, -16y and 3y, I'll get -13y. Okay. And then over here, -32, -7, I'll get -39. All right. And then what do I have? I started off with what? 2 equations and 2 variables. And then I eliminated the x through this method. And now I have 1 equation and 1. That's how it's going to have to happen. Is there some way for you to tell me an answer at this point? What if you divided both sides by -13? You would get 39 over 13. Okay. So even though that looked like it started off to be much different than the other one, and the steps were different, I got to the same place. I reduced it to 1 equation, 1 variable, and then I get an answer. So that's going to be 3. Okay, so y is 3. We know for sure the y's got to be 3. So let's do this. Let's say, here's our answer. There's an answer for what the x is, and there's an answer for what y is. We write them as an ordered pair, and I have that y is 3. I don't know the x yet, but I know that y is 3. Okay? All right, how do you think you find the x? You remember how we found it over here? Once you know x is a half, it's like all the x's up there turn to a half, and you try to figure out how to get y. So here, if y is 3, then really everywhere you see the letter y or the variable y on the page, it becomes a 3, and you just have to figure out where of all that would be the easiest place to find the x. Now, as I look up there, I think that probably out of equation A would be the easiest way for me to tell you what x is. Okay? So let's see, I'll do like this. Take the fact that y is 3. I'll sub that into A and see what it looks like. X plus 4y. Now I say x plus 4y, but we know in fact what y is. Y is 3, so we'll say like this equals 8. And now once again, I've reduced it to 1 equation, 1 variable. I can get you an answer. I get x plus 12 is 8. And then to solve completely for the x, I move the 12 over, and I'll get -4. All right, so -4 for x, 3 for y. Now just remember that when we give our final answer, we write as an ordered pair, and we write in alphabetical order. So it's x first, and then y second. All right, because x does come before y. All right, so that's how the elimination method is going to look. Now, for you to learn this, I just want you to see, why I chose to multiply equation A by -4. Why that occurred to me. because I saw that the other one had a 4. If that was that number right there, if it was negative 4, I could just cancel the x out. I would eliminate a variable. I would be down to one equation and one variable, and that's where you have to get, remember. You're not going to get an answer unless you get down to one equation, one variable. Okay? So how about this? I'll give you a suggestion because hopefully you watch this and you try to take it all in and you learn it. So I'm gonna do this. I'm gonna say, let me partition this off. I want you to try something. Given that we know that that's the answer, no matter how anybody would try to solve that problem, that's the answer. I would like you to try doing it a different way, but that it will still give you a feel for how this works. Okay? So how about this? Could we do, say, -3 times equation A plus 4 times equation B? Would that knock out one of the variables? Try to think about it. Let's see. What if you multiplied equation A by -3? That would become a -12y. And what if you multiplied equation B by 4? That would become 12y. What's -12 and 12? It cancels. You would eliminate the y instead of the x. Okay? So why not? If you're going to practice this and get good at it, why don't? That's the answer. That's the answer you're going to get. Try doing that, setting it up and writing it just like me. You'll see the y will cancel. You'll get x is 3. Then through substitution, you'll get that. You'll get x is -4. Then through substitution, you'll get y is 3. Okay? So, all right, how about you try that? You can pause the video, go through the motions, do the math, and see that you could get it right. And then you feel good about it. All right, now let's try another one like this. I think that the ones that you solve by substitution, where you directly just plug in one equation into the other, those are fairly easy. The ones where we use addition or elimination are a little harder, so I want to show you two like that. So here's another one where I want to solve it by the same method. Okay. Now, when I have a 1 right there, see that's a 1x? It's easy to turn a 1 into a 4. You multiply by 4. And you multiply by -4 so that they cancel or eliminate each other. But when you have a 5 and a 4, I can't really turn those into each other. I don't multiply 5 by something and then it becomes 4 very easily, or a 6 into a 5 and so on. So we'll multiply these in a way that we achieve their lowest common multiple, to be technical about it. All right. So here goes. I could eliminate the x or the y. I don't really think that one way or the other is easier or harder, but here goes. Here's my plan. I could make both of these be 20s, and one of them negative and one of them positive, and I could cancel the x's. Okay, so here's my plan. I'm going to do -4 times equation A, and I'm going to add 5 times equation B. Because if I do that, this will become -20, and that will become +20, and the x will cancel. So through me doing this, I'll eliminate the x. And that's the whole idea, is that you eliminate one of the variables. All right? Okay, so let's see if we can get this to work. I mean, the x's should cancel if you do it right, but because there's a lot of calculations to do all that, and you have to keep track of the numbers, be careful with it, all right? So -4 times equation A, here's what that's going to look like. It'll be -20x, okay, minus 24y. All right, and then times 61, I'll get -244. Okay, double check. -4 times 5, -4 times 6, negative 4 times 61. And then I want to do 5 times equation b. So I get 20x, 25y, and then 250. Okay? All right. So that, there in red, that was my plan. And here's how it plays out. And what do we do from there? Notice how we're real organized when we do this. As it is that we're going to add the equations together. We got the x's in one column, the y's in another, and the constants on the other side. So it can't be mixed up. You can't have x here and there. We need it all together. So if I now combine these equations, term for term, x's and x's, y's and y's, and so on, the x's do in fact cancel. That was my plan. That's how I realized I can make that happen. What do we get for y? What's negative 24y plus 25y? That's just going to be 1y. And then 250 and negative 244, that's just going to be 6. So we get an answer. There's one equation, one variable, and the answer is right in front of us. The y needs to be 6. Okay. All right. So let's do like we did for the others. Answer. Okay. X, I don't know yet, but y has to be 6. Okay, sure. Now how do you think we're going to find the x? Well, once you get this first answer, and no matter what you do, no matter how you got there, getting the other answer is always done the same way. I mean, if y is 6, look back here. I'm sorry, I didn't label that as equation B, but you probably knew what I meant. Or at least I hope so. And if at this point, make note of it. I look back up at one of those, either equation A or B, and I decide which one would I like to put 6 for y in order to find out what the x is. I don't think it's drastically easier to use one over the other. So how about this? I'm going to take that and I'm going to put it into, I don't know, I guess maybe B would be a little easier. You got 4x instead of 5x. So let's say I'm going to sub into B. Okay. And what's it going to look like if you use the fact that y is supposed to be 6 and you put that into B? It'll say 4x plus 5y, but y is 6. So plus 5 times 6 is equal to 50. So it'll say 4x plus 30 is 50. Okay? And then say we move the 30 over, it'll become negative 30. It says 4x is 20. 4 times what is 20? 4 times 5 is 20. Okay, so 5. So there, the right combination of numbers to solve that original problem is that the x has to be 5 and the y has to be 6. Okay? All right, now that's the way I would do it. If I had to solve it with paper and pencil, just like this, I would do it that way. But I thought with this one, we would do something for you to try. Because, I did this way and I eliminated the x, but it's not like that's the only way. And I guess if you're going to learn it, you might as well learn to be a little bit flexible on it. So let's do this. We'll put in this box right here. We'll say, how about this? You could pause the video and you could try a little bit different way to get this, but you'll get the same answer because there's only one answer. Okay? How would you eliminate the y? Like, what's the only other way you could proceed with this? Let's see. We turned 5 and 4 both into 20. We could turn 6 and 5 into 30. Right? We can multiply the top equation by 5 and the bottom one by 6. And we need the signs to be opposite, but we could do that. So how about this? We could do something like negative 5 times equation A plus 6 times equation B. And what would that do? That would eliminate the y. Okay? And it would instantly get you the x. But then you would go substitute to find the other answer. All right, so that would work. All right, it'd be a good thing for you to pause the video. There's the instructions. set it up, do it like that, see if you can get that same answer. Okay? All right. So far we've seen there's the substitution method, there's the elimination method, and then there's one more thing that we could do. All right? And I show you this one not because I think it's the most practical method, but everybody at least needs to be aware that we could do this. Okay? So let's say solve that, but I have real specific instructions. Let's solve it by graphing. Okay? And I want you to have this geometric interpretation of what the answer to this kind of problem means. Okay? In other words, the fact that that's an answer to this problem means that if I put 5 for the x's and 6 for the y's, it will make those equations both true. But there's also this visual geometric meaning to that answer that everybody should know about. So how about this? Let's try to solve this by graphing, and I'll tell you what the answer would mean in that context. Okay? All right, so by graphing, well, how do you graph? You could make a table. You could plug in x's and get y's and get a bunch of points and see what kind of pattern they've had. Now, in other videos, I've showed you how to draw graphs. And here I wanted to do it fairly quick because I just really want you to see how you interpret the answer on a graph. All right? So here it goes. I'll say that to graph that top equation, here's some numbers that work. Here's some ordered pairs that work. If x was 0, y would have to be 3. So it's got that point on it. And if x was 1, y would have to be 2. Okay? But I'm aware that that's a straight line. So how many points do you need to draw a straight line? Well, 1 point's not enough. 3 points is really more than you need, but 2 is just right. So I know that first equation, if you wanted to visualize it, would be this line right here. Okay, so there's y is equal to 3 minus x. All the points on that line work in that equation. Now what about this other one? We can do the same kind of thing. I'm going to just, off the top of my head, I'm going to choose some points and draw what the graph would be. So what if x is 0, y is 1? So that's this point. And what if x is 1, y is 2, and that happens to be this point? Okay? So there I drew the graph of that other one. There's this one. Now, what do you think the solution to that is? And maybe looking back, why do you think we write the answer to these problems like it's a point? See, when I wrote 4, negative 3, that's how we write points. Like, you see this point right here? That point is 1 for x and 2 for y. So we might say, see this point, 1, 2. Well, all right, here's the story. The solution to this problem is such that if you graphed both of those, they would intersect at that spot. And the solution to this problem is such that if you graphed each of those, they would intersect at this spot. All right, you get the idea. So you can solve a problem, I mean, hypothetically, if you took the time to draw the graph and you could draw nice straight lines and all that kind of stuff, the solution is the point of intersection. Okay? So that's always going to be true. The solution will be the point of intersection. And you could think that all those other problems we did, that's what the solution meant. Okay? So let's say this. We solved it by graphing. Okay, I got a nice picture there. It's completely undeniable that that's the spot where those two lines intersect each other. So we'll say the solution is 1, 2. All right? 1 for x and 2 for y. All right. So that's what solving by graphing means. Now, you have a way now to think about what all those other answers meant. There's some problems in the assignment and in the book where sometimes it will just give you an answer and ask you to check it. And I haven't done that yet in this video, so how about this? Since if I was going to solve it by graphing, that would rely on me actually being able to draw a nice picture. You know, if my marks were a little bit off, or if my ruler weren't perfectly straight, and you know, it would be hard to do it like this. I'm still totally sure that's right though, but how about this? How, if you got an answer to any problem, how would you check it? What makes that right? Like, who gets the final say on that being right, and how do you know? Well, it's like that pair of numbers works in both of them. If you put 1 for x and 2 for y in both of them, they each work. They are each true. So look, that first equation, if you put 2 for y, 1 for x, says this. And that second equation, if you put 2 for y and 1 for x, says this. Do you agree with both of those? Are those both true? Is 2 equal to 3 minus 1? Yes. Is 2 also equal to 1 plus 1? Yes. Okay? All right. So that's the graphing interpretation. All right. So we'll look at some others in the next video. This is enough to take in for this one. But this will only take you through most of that first assignment that we have for test 4. All right. There will be more in a video coming up pretty soon.